Good afternoon, everyone. Welcome back to the important session of this training program, which is assessment of water resources in a basin. So, particularly, yes. So, surface water assessment, how to estimate the water balance for a river basin, that will be covered in this session. So, surface water assessment will be covered. How you compute the surface water, including how much amount of water is being generated by rainfall, how much water is being imported in the basin from the transboundary area, upstream catchment area, and how much water is being extracted or in the evapotranspiration format. How much is the loss of water, whether it is irrigation evapotranspiration or reservoir evapotranspiration or land surface evapotranspiration. So, in this session, I would like to brief you about the brief methodology, the standard guidelines, Central Water Commission, Ministry of Jal Shakti, how they are calculating the water resources for a particular basin. And after this presentation, the presentation will be around 25 to 30 minutes. And after this, we have prepared an Excel sheet where you can put your values, the catchment area, the rainfall value for your basin. Meghalaya, you can put the rainfall value and higher rain because it's ranging around 3500, 4500 something, and then for plain area, downstream area, you can use the rainfall amount depending what is the annual rainfall of your catchment or sub-basin. After this, you have to put, if you have reservoir, then you have put your reservoir loss, reservoir water loss, and then if you have command area, the water diversion for command area, the irrigation water loss, then you have to put some values there. So I'll let you know how to put those information, and this will be the rough information. If you calculate the exact water requirement, then water resources availability of your basin, then you have to, some empirical formulas are there, then some guidelines are there, but here we will estimate the surface water using some standard method which developed by Ministry of Water Resources, Central Water Commission. So, as I mentioned, Ministry of Water Resources, Central Water Commission has published one document, one report, because the CWC is, assessing the water resources of the basin since, its setup. So, 1990, 1993, then 2000, 2014, then recently 2024, they have estimated the water resources for river basins of India. Then they have estimated the water resources potential for all river basins of India. So this document was published by Central Water Commission, Assessment of Water Resources of India, in August 2024. And in the right side of this slide, you can see the empirical equations and formulas are given. So, you can see the major part of the water, the surface water, is being generated by rainfall in any river basins. If there is no upstream contribution in your catchment, like if you see, we take example of any river basin of Assam like Beki, Subansiri, there is some contribution from upstream states like Arunachal, and then upstream countries like Bhutan. So if you have the gauging site near the transboundary area, then you can consider that what is the discharge or water level, because ultimately you are going to estimate the discharge. So if you have the water level, then you must have one correlation, water level discharge correlation, you call rating curve. If you don't have any rating curve, then there are some sites where then discharge is directly being measured by competent authority at that particular locations. So you can use this discharge data and you can estimate what is the water inflow is coming in your basin from upstream catchment. and then you should have one outlet, defined outlet of your basins. You can use intermediate point as well, because ultimately your goal is to estimate the surface water potential that particular location. So you have to consider the entire upstream contributing area. So precipitation is the major source of the water in the basin, and another one is imports. Import means nothing but it is what is the contribution coming from upstream catchment or upstream the boundary, another state, any what discharge measurement from upstream catchment. It doesn't matter if this is exactly should be on the boundary of this transboundary area, but you can take slightly downstream and upstream, whatever information available nearby that location, you should consider that information while estimating the water resources for the basin. Another, because this is your total input, this is nothing but simply a mass balance equation. Okay, so what is the input and what is the storage within the system and what is the output? That is the simply a mass balance equation. So your input is precipitation and the inflow from upstream catchment. Okay, that is your input. Now, what is your output? Output is losses of the water, which is land surface evapotranspiration losses, which it has denoted ETN. This is TN, and means natural evapotranspiration natural. Then you must have if your basin area is larger, then you must have some reservoir or storage area in between the your steady area. Then the reservoir evapotranspiration should also be considered, though it's if in terms of total water availability this is negligible, not much, but in order to estimate the accurate surface water, you should have this information with you, the reservoir evapotranspiration losses. Then export is nothing but this, what is the changes in the discharge, and discharge being measured as what is the changes at the system, whether it is changes in the reservoir, whether it is changes in the soil moisture. And model runoff is nothing but if you deduct the losses from the precipitation and inflow, this would be your model runoff. So the equation has been given here, the P precipitation plus I inflow from upstream catchment, then ET means total evapotranspiration losses, which includes all kind of losses of evapotranspiration losses, then QM your discharge, and then delta S is the change in the storage or change in the the moisture content within the system. Then your model runoff should be P minus ETN. P means precipitation volume. We will estimate all those these details in volume term in MCM or BCM. Okay, so because we are having the catchment area and then we have the information of rainfall, then we can directly multiply and considering the unit transformation, we can compute the volume of the water, what is available within the system and what is coming from upstream catchment and what is releasing in the downstream part. Then water availability is the RM plus ETI, ER minus import. So we'll discuss all those parameters in the coming slides. Just to tell you background of the surface water assessment, why this is required. This is the important activity in while estimating the water resources project. If you are planning to consume water or divert water from the system, then you should have this information with you, what is the available water in my system. So if you are setting up a project of inter river basin transfer, you are setting you are allocating some water to industrial use, the irrigation use and some domestic use, then you should have this information with you, what is the availability, because based on availability, like yesterday's session we have discussed the optimum allocation of water. If you have if you have information what is the availability of water, then you can prioritize this water I would like to use in this domestic first, then irrigation first, then after industrial, after the livestock, whatever, based on availability of water. And then you are planning some projects, then depending upon the availability of the water in the system, you should plan. Then your first task is to estimate the resources available in your basin or in your system area. So this assessment is nothing but the sustainable development or management, optimal management of the water resources in any region, any basin, any boundary. Then it's provides on basis of providing planning, implementation, and maintenance of the water resources and project effectively. Effectively, we can use if you know the what is the availability of water resources in this basin. Then IWRM practices. IWRM practices they recommending that you should have optimum utilization of water resources, optimum as well as sustainable use of water resources should be there. Then water resources assessment comes in picture. Government of India, the Central Water Commission, Ministry of Water Resources, they are estimating water resources for India. The basin wise assessment they are doing, then compiling on this information, they are computing one single unit for India, what is the availability of water resources. So over the years, you may see in this slide in the table, the assessment of water resources is increasing over the years. Like first estimation was in 1903, first irrigation commission using empirical formula, coefficient of runoff. So a rough estimation was there. Then the water resources of the India was around 1440 in terms of BCM. BCM is the volume unit. Then another empirical formula is the Khosla formula. Again 1949 increased by 200 BCM, 1673. Then again 1960, 1800, 1988 CWC estimated this. Then 1880. In 1993, Central Water Commission again estimated this potential for coming 1869, 1999 again estimated. Then you can see there is an increase in water resources assessment. So 2024 also they have estimated, and this is coming more than this value which is given in the about 2000 BCM. So this assessment is continuous. Ministry and the competent authorities are computing those assessment on regular basis to assess what is the potential available within the system. And this is on larger scale. For India scale, some agency like Water Resources Department, some Irrigation Department, Horticulture Departments, PhD, they are also assessing those availability of water resources within the basis depending upon the requirement. What is the requirement? If they are planning any scheme, they are planning to divert the water from the system, then they are doing their own studies depending upon whatever methods they are using. So in the assessment, I would like to take 2 or 3 methods here. One method is given, mass balance method, considering the losses in the system, which is basically evapotranspiration losses. So that I will discuss, which has been given in the Central Water Commission report. Another method, we can do a rough estimation, but you should have the availability of long-term data with your department, with you. Long-term data means the hydrological assessment, you need to have at least 30 years of time series data with you, so that you can compute what is the inflow to the system and what is the outflow in the system. So in this example, you can see, because I have prepared an Excel sheet, I will be sharing this sheet with you, then we will be having some hands-on on this. You put some, the yellow highlighted, cells are the cells where you need to put some values, because considering the availability, the catchment area, your region, it depends on what scale you want to estimate this surface water. So if your basin area is in beyond 1 lakh, 5 lakh square kilometer, then you have to put this value. Otherwise, the small catchment also you can do this exercise and you can estimate the water resources. So this approach, the approach I am showing in this screen, you can use when you have the long-term data available with you. Long-term means, when I say long-term, it should have at least 30 years of data, plus minus the missing value you can fill those gaps considering the, the suitable method, but you should have at least long-term time series data with you. Long-term data means the discharge data you should have with you. So in this picture, in right hand side, you can see this is nothing but a pictorial of view of the catchment area. Okay, this is the catchment area. The yellow portion is the gauged catchment area. So gauged catchment means at the outlet of the catchment you have a monitoring or observation site where you are measuring water level, discharge, water quality, sediment. Then specifically the water discharge you are measuring at the outlet of the catchment, which is called gauged catchment. Ungauged catchment, the downstream part is ungauged catchment, and you have one gauging site in between this gauged and ungauged catchment area, and you don't have any assessment site or monitoring site at outlet, the basin outlet. So in this case, because the entire catchment you are having only one monitoring site, the measurement site, okay, where we are measuring the water level and discharge, only single site you are having, and you want to estimate what is the available water at the information at the outlet of the catchment, then you have to use this table which I have prepared. In this, what you have to put, what is the average annual discharge available at the particular site, because you have 30 years of discharge data for your gauging site. So you have to take average value. Let's say 20,000 cubic I have considered. This is not a value for any specific gauging site, but the dummy values are there. You can use your own recorded values, measured values in this. What is the average annual discharge of the long-term data is average of 30 years time series after filling those the gaps, if you have any data gaps in your data. 20,000, the unit is cubic. Cubic means meter cube per second is the rate. This is the discharge rate. Then catchment area till the gauging site, because your measurement site is contributing some area and you are measuring some data for the contributing area only. So your catchment area should be in square kilometer, let's say 5 lakh square kilometer. Then I have already put the formula here. Considering these two values, it will calculate the water yield. Water yield is nothing but what is the potential per square kilometer area, what is the water potential in your basin, irrespective of your size of the catchment area. So I simply done some unit conversion, and it has calculated the water availability per square kilometer per unit area. Means this is the water yield for your catchment. Now, because your site is up to that particular location, now you want to estimate the water availability for the downstream at the outlet of the catchment, then you should also consider this area in the picture. Then your catchment area at the outlet, it's 6 lakh square kilometer, and the 5 lakh your gauged catchment, and 1 lakh is your ungauged catchment. The total catchment area is 6 lakh square kilometer. The moment you put this value here, then it will automatically calculate. It means this Excel file, I will be sharing this file with you. It will calculate what is the computed average annual discharge at the outlet of this basin. Is nothing but it will calculate, considering the entire area, the yield it will use for the gauged catchment, and the remaining information like the catchment area and all, it will use from the entire catchment area. And computed average annual volume, cubic, 24,000 cubic. As I mentioned, this is the rate, meter cube per second. That particular section, that particular cross section, 24,000 meter cube. 24,000 meter cube per second rate, the water is passing through this rate, okay, in the system. So you are estimating the water resources for annual scale. What is the annual water availability in your basin? Then in this formula you have to multiply 60 then again multiply 60, second, then minute, then 24 days, then 365. This is the simple unit conversion for estimating the water for annual basis. So it is coming around 7,56,864 for in the MCM unit. Then MCM again, if your estimation is in the meter cube, then again you have to divide by the 1 million in order to convert in the MCM. Then again BCM, you have to divide again by 1000. So the water resources availability using this method is coming around 757 BCM. Okay. So considering this, this method will work when you have long-term data available. At least one gauging site data you should have in your basin. Discharge data you should have in your basin. Then you can calculate this, irrespective of your size of gauged and ungauged catchment area. So this method is valid only when you have long-term, at least 30 years time series discharge data available with you. Any doubt, any confusion up to this point? You can estimate if you have recorded values, the measurements at a particular site, irrespective of the location of the site in your basin, then you can estimate the water resources, surface water availability of your basin at the outlet of the basin using this method. Okay, by yield method. Okay, there is no gauge site, then we'll use the another method. Okay, which I will be coming the another method. Okay, so next method is this method has been given in this report, the Central Water Commission report. So in the Excel I have prepared this, what is the catchment area of your basin in a square kilometer. First you need to have to put, then time period, because you are estimating the your water availability on annual scale. If you are monthly scale you are estimating, then monthly values you need to pick up. I am estimating here on annual scale. Then precipitation in mm, 3500 I have considered. Then it will convert it in the volume, the BCM. All the formula because I will share this Excel file with you, then you can see how the formulas units have been converted. So it will give you your what is the volume of water being generated by X amount of rainfall. If your rainfall is 3500 mm, then on annual scale what will be your value of precipitation volume. This is the volume of water generated by precipitation without considering the losses, because there are several losses are there. So after considering, as I mentioned in this report, the guidelines I considered 3 losses. One is natural evapotranspiration, land surface evapotranspiration. This is the major loss in the system. Okay. So by topography, vegetation, because rainfall, you don't have, you cannot convert your rainfall 100% to the runoff. There are some losses. So evapotranspiration losses had been considered. This is coming around, and this how we calculate this ET losses, that I'll cover in the next slides. There are some data available, information, and the raster data sets are available from which we can estimate those losses. They have considered some assumptions. They have considered some assumption losses. So yes. So your infiltration will go to the change in the system because there is a delta. Delta is there. Delta is also there in this. So you come to know the information. See this slide you can see. Recharge, groundwater recharge. There is one component. So whatever delta is there, delta comes in picture here. Deltas. Delta will come to know when move to the next slide. So we'll get in clarity. So your model runoff is 1300. What is model? That you put natural evapotranspiration, precipitation minus natural evapotranspiration, your model runoff. Then there are two components are there. One is irrigation evapotranspiration, I mean irrigation losses. So it considered whatever your field distribution, the losses, conveyance losses, everything they have considered this. So this is in terms of total water availability. This for the basin, this is not much, but the guidelines, the thumb rule is there. The 40% of your whatever X amount of water is you are diverting for the irrigation, then your 40% losses goes to those, I mean, irrigation losses. Okay. Then there are some losses, the reservoir evapotranspiration losses. These are, we can calculate from, NWIC portal, they are having some data, the reservoir, list of reservoir for the Indian scales. And then for irrigation, the command area shape file is also there on the NWIC portal. So I will let you know where from you download those files, and you can see what is the water spared area in your system basin. Then you can estimate what is the reservoir, I mean how much water spared area is covered by the reservoirs. So the reservoir evapotranspiration losses is, I mean, usually takes 1% to 2% of your storage capacity of the reservoir, I mean on the rough estimation. Then again the catchment area, then total evapotranspiration ET, then transboundary inflow. If you have an inflow from the upstream transboundary catchment area, then you also consider, because this is not the flow being generated from your catchment. Okay, so you have to deduct this loss. So finally the change in the storage delta S is coming P plus I mean total inflow volume of water generated from the precipitation and from inflow from upstream catchment, and then minus ET minus QM. QM is the whatever you are discharge. Then this is the formula. ET means ETN, ETI, ETR, and then the irrigation input. This irrigation and reservoir evapotranspiration losses are man-made. They are not may not be applicable to all the river basins. Okay, they are man-made, so these are losses have to consider, and their values have also been considered. What is the range of values these losses are there? Then delta S is there. Then ET plus RM. RM is if you deduct the losses from the rainfall, then RM is there. And model runoff is there. Then change in the soil moisture or the storage or change in the volume in the system. The RM is nothing but precipitation volume minus inflow from upstream catchment and evapotranspiration losses. Here is the total losses we are considering. Then water availability is RM plus ETI minus ER, because the ETI, irrigation, as well as this reservoir losses, we can calculate from some methods what are the losses, and inflow we know from upstream catchment. Then your water availability for this basin is you can calculate. So these are some definitions. You can go through this report, and you can see what is the method for because earlier studies, the empirical methods were there. These studies, they have considered the evapotranspiration is the major losses they are considering in this, and accordingly you can plan the consumptive use. As I have already discussed this, the domestic industrial livestock consumptive use and the water demand you can estimate if you estimate your water potential in the basin. The domestic water demand, there are some guidelines, 135 liter per capita per day LPCD for urban, and then 70 LPCD for rural population. There are standard guidelines. Then industrial demand of the area is not readily available, but same assume 50% of the domestic demand. Some literature methods are recommending this value if you don't have any data for your particular basin. Then the industrial water demand you can estimate per industry wise. You have cotton industry, you have some paper-based industries, you have some machineries, the construction industry. What is the water requirement? There are some guidelines. You can estimate this water requirement depending upon what is the production rate of your industry. production rate. But these information generally, not available for a basin, and either they are not available or not readily available to be used for this calculating this. So there are some guidelines to estimate the industrial water use for per hectare, and what is the area in this industrial area coverage for this particular zone, particular basin. Then you can estimate. There are some guidelines are there. I will discuss all those guidelines. So in this report, let's come back to the assessment report. They have estimated this surface water availability for the entire 22 river basins in the India. So I am considering an example of this Barak River Basin. Barak River Basin they have estimated. So Barak River Basin, and this is the map. Then NRSC, this is the LULC map. These categories are there. Then coming to this rainfall, this is the rainfall map, the annual rainfall. So the average precipitation, like the first cell of this Excel file, this is the they have considered the annual rainfall. You can see the range from 0 to 9,000 mm. Then average you can take for your basin. You can put that Excel. Then the estimated the precipitation volume I have converted from the formula. This is coming around 134 BCM for, and using the annual rainfall 2,800 mm in the Barak Basin. So this is annual variation. If you estimate for current year 2026, you might be having some different value. Otherwise, they have mentioned from 1985 over the last 35 years how the water resources, surface water resources is changing in your basin, the Barak basins. Now coming to this land surface losses, the major loss. This is no directly there no this BCM is generated by this amount of rainfall, annual rainfall 828 mm of you are talking about rainfall or this one? You are talking about this one? At 128 mm is the ET, evapotranspiration. You convert this, considering the catchment area of your basin. No, you mean this at 28 is generating this 41. Okay, you are okay. This got your point. This has converted, and this amount of evapotranspiration generating this. This is not directly linked to that value. This is delivered. And for NWIC portal, NWIC you are you aware the NWIC portal, they are having that lot of information. You have gone through one class which is basic GIS, how you can create maps, what are the shape files, vector, raster shape files. Then you can use, if you are using the GIS platform, then can use the NWIC data. There are a lot of data freely available for entire India. So for example, the reservoir, what are the reservoir locations in India? So in your basin, if you want to see what are the reservoir area, spread area, then you can see this file. And another, you can see what is my this command area in order to estimate this irrigation water requirement. Command area shape file is also there in the NWIC. $1991 annual value. This is annual average. Average of 30 years. 35 years. Annual average value. This is Then same thing, I mean, the water availability of your basins, average water availability, you are simply trend line, you have straight trend line you have generated. So this is average water availability in your basin, considering all those, I mean, this, using the empirical formula. What you have considered, the evapotranspiration, your rainfall, precipitation input, the inflow from upstream catchment, and then considering all these values, you have, I mean, you can estimate the time series values of your water availability of your particular basin. This is how, I mean, water resources assessment is declining. I mean, this Barak and other basins you can see, I mean, these values are given in this report. Now, these are methods where you can estimate the water resources using the available information, the empirical data. If you have rainfall, you have some amount of volume the rainfall I mean generates, then considering some losses deduction, you can estimate. The first approach was when you have long-term data for at least one particular gauging site in your basin. Now coming to the, I mean, exhaustive or the comprehensive method, which is modeling systems. You can use hydrological model, and this will be the accurate estimation. The earlier estimation were depending upon some I mean rough estimation, and depending upon the availability of resources, data, time. So some empirical formulas, some assumptions have been used on those, I mean, 2 or 3 methods. In this method, if you use the water resources assessment, you do using the modeling tools, then it will be the accurate input. Like all these information, you are saying the infiltration where, I mean, in the modeling, you are considering the rainfall as an input, but same time you are also considering the losses as infiltration losses, the evapotranspiration losses, the agriculture, I mean the ET losses, everything you are considering here. And then runoff calculation, you are also considering some losses, the routing and all you are considering in the model. So you should have these information available with you, like land use also you are using in this method. So there are some tools you can estimate the water resources and the water availability for your basin. Like SWOT is the one tool is there, soil and water assessment tool. I mean, how many you are aware of this tool? I mean SWOT. Can you raise your hand? Okay, good, not much. So again, the semi-distributed hydrological model considered a lot of data set, including temperature, rainfall, evapotranspiration, land use. So it will, what I mean, in the GIS you have considered, or we will be considering how to delineate the watershed. So in a river system, the parameters may not be, I mean, always there are not uniform for the entire catchment area. There are some changes. I mean, the hydrological characteristic is changing in the basin area, upstream to downstream. So in the modeling system, what we can do, we can first delineate the watershed, and we divide the watershed in the sub-catchments, number of sub-watershed. Let's say about 20 sub-catchments. Then in modeling, SWOT or HMS, any hydrological model, you have to put a single parameter for each sub-watershed. And it will vary, because in for some watershed you are putting some LULC value, land use value, the manning roughness, then you are using some another value for the downstream, considering what is the topography and what is the land use pattern of their watershed. If you are dividing the entire catchment in the 20 sub watershed, and one of your watershed is having this thing, your capital of this state or your city is there, the settlements are there, then the surface is paving. I mean, the losses will be minimum at that particular watershed. And whatever rainfall will be there, more than 90%, more than 85% will be converted in the runoff. But in the agriculture field, in the forest area, where the soil percolation or, I mean, this infiltration losses are higher, then hardly you will get the conversion rate of 30%, 35%, even up to 25-20%. I mean, 100 mm of rainfall is occurring at that particular watershed. The 20% is utilized in the runoff conversion. Remaining is losses, the groundwater losses, whatever the initial losses are there. So in this SWOT model, there are some limitations also. Lot of data requirement is there. On each basin scale, you need to have some data with you. That only you can use, and then time consuming as well. The estimation would be very accurate, but you need to have lot of data set, time series data sets with you. And another hydrological model is HMS. So HMS is hydrological modeling system developed by US Army Corps of Engineers US. So it is widely accepted model. Open source model you can use. We will be covering this model in our classes, next classes, hands-on classes. We'll ask you to install this model, and then after installation, you'll get to know, how to delineate the catchment within the HMS system. And one more thing, these over the years they have developed, their model such a way that maximum the GIS functionality are inbuilt in the model. Earlier days, while delineating the catchment, we used to, use this GIS platform for delineating the catchments, and then the input of the catchments to be, was imported in this main model. Now the HMS comes with this functionality, GIS functionality. Whatever DM downloaded, the topographic elevation model you have downloaded for your catchment, you have to import this DM in the HMS model. It will automatically delineate and create the catchments for your area, and threshold you need to define. If you want 5 subcatchment of your basin, then you change the threshold. If you want 20 subcatchment, because there are variation in the hydrological characteristics of your basin, you want to capture each and every variation, then your number of subcatchments should be higher. Multiple catchments should be there. Then you change the threshold, you can delineate accordingly. And your rough estimation, if there is no hydrological variation in your basin, then you can use 4 or 5 subcatchments. You can estimate those parameters for this. Then Basin is the tool. We will cover this in the next training session. We have not considered this. This is a tool which is used to provide the water allocation information. From this tool we can use how we can optimize the water allocation for different sectors. So Basin is the tool we can use. It will also estimate the water availability for this, but apart from this will also allocate the water resources for the different sectors. Comparison of those tools, their functionalities, you can see here. Rainfall runoff model, the models which are converting rainfall to runoff after deducting the losses. There are some losses. Then these two models, SWAT and HMS, can be used for this. Basin is not for that purpose. Long-term water balance, again all these 3 models are suitable for this purpose. Then groundwater, you can use the SWAT for groundwater estimation. These remaining 2 models, though the HMS also, there are some functionalities we can use the groundwater aquifer information in this HMS, but this is not widely used for this purpose. The SWAT is the better one for this purpose. Then reservoir operation, the limited SWAT also consider. Then HMS also considers the reservoir operation rules in this system, and Basin also consider this. Then water allocation, Basin is the only tool. There are some other tools, but we are comparing here 3 modules. So these are their strength, and weaknesses. Then climate, land, LULC change, impact of climate change, we can use, all these 3 models depending upon the requirement of this. These are some links where we can download the data for water resources assessment. Like if you want to see what is the average annual rainfall of my basin or catchment, then can use the graded data of 25 kilometer by 25 kilometer graded data provided by India Meteorological Department, and this is available, I guess, free of cost. So you can download this data, you can convert, and you can process this data for your particular catchment only, and then you can estimate the rainfall, average annual rainfall. Then one parameter we have considered, evapotranspiration, okay, the land surface evapotranspiration, natural evapotranspiration. So USGS has provided this information. This is available for entire area, entire globe. You can download this from this link. Daily values are there. You can extract. For example, you would like to estimate this evapotranspiration for your basin for 2025. Then you download all 365 or 366 files from there, they can use average value, I mean, on annual scale. Then, as I mentioned, the command area and reservoir details, because the save files are also available there, and this data in Google Earth form. I mean, you can also use this. You can visualize, see the KML file. You can see, you can download, and you can visualize command area. They have uploaded, prepared there. Other than two files, because these two information from NWIC you can use for water resources assessment point of view, but there are several other files as well, like for block boundary, the land use pattern, the rainfall variations, the hydrometeorological gauge network. All those files are available on the NWIC portal, and you are working in this, I mean, water sector WRD from the state government, so you must be aware of this NWIC portal, because all the state agencies, specifically WRD, water resources departments, are using this portal. I mean, they call it WIMS when the states are using this portal. So these information are available on this NWIC portal. You can use and download. You can download and use those details. So this is the brief overview of the presentation. So I will be copying this file, the Excel file there. You can have a 10-15 minute exercise. You can estimate. If you have any doubt, you can ask there in the during the hands-on session in the training hall. And apart from this, if time permits, we will start, because we have allocated this thing, water demand estimation procedure. I mean, how to estimate the demand, I mean, the domestic water demand, this industrial water demand, irrigation water demand. And there are some methods. So we will also be covering this hands-on demonstration along with this exercise. So we'll use this. And as I was discussing with Director Sir, from tomorrow onwards, we'll be having, I mean, the theory session will be limited up to 15, 20, 25 minutes only. Then we'll be having some hands-on sessions, so that you can interact more, and you can discuss, you can interact, and you can do the exercise by yourself in the system. So that we have decided this, because theory, I mean, in this last 1.5, I mean, days, you might have understood that these are the components which will be covered in the master plan. Okay. So introductory session, that is fine to covering all the points, all the topics, but now specifically we will be targeting one by one topic, and we'll have the presentation first for 15-20 minute presentation, then we'll have the hands-on exercise almost in all the sessions. Okay. So thank you very much for your time. We'll resume a bit. Maybe after 10-15 minutes we'll resume in this lab for the hands-on exercise for water demand, as well as for estimating of water resources. Thank you. Interesting, because you are using this area, telling the map. You might have seen the good map. How to prepare those? How to prepare the color combination? How to prepare a good map? Showing the variation of high, low, medium. Only for